So this is going to be Unit 2. Unit 2 is going to have to deal with two quantitative variables. All right, so again, making sure that quantitative is going to be, we're going to move away from categorical variables, which was Unit 1A, kind of 1B moved into quantitative or numerical variables. So the same thing here. Again, we're going to move into, we're going to stay in that numerical area. So we're going to have two variables. So in a two variable system, we're going to be able to plot that on two different axes, okay? Obviously, remember, we have a y-axis and we have an x-axis, okay? The variable that we place on the y-axis is going to be the outcome, okay? So it's going to be the response variable is what we're going to call that, okay? As far as trying to determine which variable is which, we're going to use one to predict the other, okay? Or explain the other. So this is going to be the explanatory variable. Okay, or help explain, again, help explain is going to go on the x-axis. Okay, anyway, it's going to help explain or influence the changes in a response variable. So that's our first goal here, is we're going to get a couple different variables, and we have to identify which one's going to be explanatory variable and which one's going to be the response variable. So Mrs. Sapp is interested in the relationship between hours students spend studying, so hours studying for an exam, and their score on the exam. So there's my two variables, more specifically hours and score, there we go. So one of those is going to be explanatory and one of those is response, and we have to think to ourselves, are we going to use the hours studied to predict an exam score, or are we going to start with the score and use that to predict how many hours they studied? So in this case, the better of the two probably would be leave this as our explanatory variable. Hours studied is going to have an indicator on our response variable, the score on the exam. Okay? In the second one, a researcher is interested in the effects of a new drug on reducing muscle spasms. So this one's pretty much, it's really hard as far as we have a new drug. So obviously, and again, they didn't go into great detail here, but this might be milligrams of the drug as far as 1 milligram, 2 milligrams, 3 milligrams, etc. And then the reduction of the number of spasms. Okay. And so therefore, are we going to use the drug as my explanatory variable and the spasms as response, or are we going to use the number of spasms to predict what was the drug amount of the drug? And again, we're going to use this as my explanatory variable and this one as my response for that. Okay, so we can make a relationship between any two variables we want. What we have to be, and we'll talk about it later as far as causation goes, one doesn't necessarily cause the other. There may be other things in the background. They're called lurking variables, but I'm getting way, way, way ahead of what we need to be able to do here. Okay, so this first page is just an introductory page. It's how to make a scatter plot. The AP exam is not going to be a ton of data entry. I'm trying to remember, typically they're going to give us a scatter plot. However, we're going to, in here, we're going to make a few scatter plots along the way. So we might as well get practice doing those, okay? So we have to decide, again, we have to go into this, we're going to decide which one is the explanatory variable and which one is the response variable. So when I come down here, am I going to use body weight? Am I going to use body weight to predict backpack weight, or I'm going to look at a backpack and that's going to help me predict how big a person is carrying that backpack? And again, this one kind of could go either way. However, in my notes, and we'll just keep going with that, I use the body weight as the explanatory variable to help predict, or response variable, how big a backpack that person likely has. Okay, so again, we have to label and scale that axis. Again, that's going to come back to, again, the cheap points, as I like to call them. And so we have to be able to do that. Now, I can see that, again, scaling sometimes becomes an issue. I know that, we could start this at 0, but then my scale is going to, again, this is going to be 0, 0. However, my scaling is going to get way off if I don't start until I get out here to 100. And you can't see that marker. And, if we had to wait till we get out here to get to 100, that's wasting graph. So a lot of times we will see broken graphs. So I'm going to go ahead and break this graph, and I'm going to break this that particular axis as well. I'm not breaking the graph, I'm breaking the axis. Okay, and looking at my notes, I started with 100. And attempt to scale them as close to the same increments as possible. I'm not doing a very good job of keeping consistent with that. I don't know how far I got to go. 187, so that should cover me. Okay, and over here, I think I scaled it by 2s. Okay, and again, so we have scaled an axis. I haven't labeled it yet, so this is going to be our body weight. And our body weight, again, a lot of times it's good to write down that unit there. It's going to be in pounds. And this is going to be backpack weight. Also in pounds. Okay, so we have our axes scaled and labeled, and now we're going to plot these points. So we're going to plot 120. Here's 120 and 26. So that point is going to be there. 180. So my next point is going to be 187 and 30. We're going to make that into an ordered pair. So here's 187, and it's going to go up to 30. 109 and 26 is back here. 103 and 24 is going to be there. 131 and 29 is going to be there. 165 and 35. Ooh, heavy one there. 158 and 31. And 116 and 28. All right, there they go. So that is going to be my scatter plot. Okay. And later on, we're going to draw in what we consider a line of best fit, or least squares regression line. We'll get into that in a second. So the reason we want to make a graph is we want to then describe the relationship between these two variables. And we're going to describe the relationship between those two variables on the next page, but that is actually for a different lesson. However, since we are here today, and this video hasn't lasted very long, I do want to go ahead and introduce our calculator to this process. So if we come over here, I have entered my data into L1 and L2. And what I also wanted to point out, because the first time we do this, we're going to get an error message. And I wanted to show you why. So I've got the same pairs going on as far as I have 120 and 26. So we have L1 and L2. If I scroll down here, you're going to see that I actually ended up with an extra. I've got a 0 weighted human that can carry around a 3-pound backpack. So my, not 0 weighted, no weight. So my lists are of different length. And I want to show you what happens, because that's one of the most common errors that happen. And I just want to show you right off the bat. So again, we're going to go into our stat plots. So we go shift and y equals. And we're going to go into plot number 1. Okay. And I have to turn that on. So I hit enter. Now, if we look at our graph types, that very first one there is our scatter plot. So we're going to choose that one. Okay. As we come down here, the X list is going to be my explanatory variable. The Y list is going to be my response variable. So those are already set like I want them. We decided that my explanatory was an L1, my response was an L2, and we're going to come down here, and I don't know why this is, okay, it's going to graph at this in red. Okay, now if I hit graph now, actually I'll hit graph now because I'll get the error message. Okay, now notice that it says the error is invalid dimension. So what that means is one list is longer than the other. They don't have the same dimension. So if I hit number 2, we can't go to that. So I got to go back into stats, and I got to go into edit, and I have to delete this number over here. So now my lists are the same length. So now when I hit graph, I am not going to get an error message. But the problem is I don't see anything because my window range is it's too far off of what I need to see. So I am going to hit zoom. Okay, again, it's really hard to see. I wish I had some type of pointer. Top row, third button over is zoom. Okay, and option, and this is gonna be weird because I'm used to zoom 9, which is zoom stat on your cal and in your TI-84. Zoom stat is actually number 5 on this. Okay, so there is going to be the scatter plot, and it looks so funny on this. How about I tilt it up this way? That looks a little bit better. I guess I need to remember to turn my iPad so it's sideways, so it's this way when doing these. And what happened is now we can hit trace, and so if we, and again, I wish I had a pointer that I could show you. If you look at the very bottom of the screen, we see X is equal to 120, and we see Y is equal to 126, and we have a black dot there. If I hit a right arrow key, I start bouncing around the graph, and it highlights those points. So again, our calculator can make a scatter plot for us to do that. So I just wanted to introduce that real fast to us because we had that ability. So I'm going to shut down